Touch my tra-la-la.
Ninja Taramaya.
Looking for some love.
Hey homie, you look like you're good at couples. Get in the car, fool. Hey, stop or I'll shoot you.
Oh, you touch my tra-la-la.
Hey, get in the car.
What you gonna do? What you gonna do when they come for you?
Hey, Austin, how you doing?
Good. You were overspeeding at 2 miles per hour, sir?
What are you talking about?
No,
Overspeeding?
you were overspeeding. And I can prove it. According to the interval 2 to 4, you were overspeeding, sir. Look at this graph. Let me explain it to you. According to my speedometer, the velocity of your car is given by the equation v of t. Graph v of t and y equals 2 into your calculator. Next, we must find the intersections by using second calc intersect and just window accommodate the interval 2 to 4. When this is done, we find the two intersections at time 3.1276 and 3.4734. Sir, you went above the speed limit twice.
Hey. Oh yeah, that's simple. It makes sense.
Yeah, as the authority of this town, sir, I must give you a ticket now. But hold on, can you hold this for me? Because I think I have a Facebook notification. Hold on.
Órale,
Awesome! I'm going to a wedding this Saturday. Oh, so your ticket. Okay, let me see.
Ticket.
Your ticket.
Thought you
So
were
I only
cool,
have
man.
a pink pen. Is that okay?
Whatever.
Alright. Your ticket for overspeeding at 2 miles per hour. It's gonna be $1 million, sir.
That's nothing.
Alright, can I have my speedometer back?
Nope.
Give it to me! Alright, goodbye.
Oh man, where am I right now? I must figure out the function. Oh, I can figure out the function using the function the police officer said. But how do I do that? Oh, calculus god, please help me.
Jeff, remember when I touch you.
Yay! Oh, thank you, calculus god.
Hello, I'm Jeff, you know, the guy in the back seat. I must now find my position, but before I do, I must reveal my true identity. I'm actually Russian. Okay, so in order to find my position, I must develop an expression. This can be done by taking the initial melt at time 0, which is then added to the integral from 0 to 5 v of t, which I overheard the cop saying. The next step is to take the expression 10 plus the integral from 0 to 5 v of t. Once we have this, we will get the answer of
Oh yes, I'm a position negative 9.2073.
What good is that gonna do, fool? You're still not getting out.
12 seconds later.
Hey, sexy.
I'm on the case getting sideways. $4.05 on the highway. You know what? Paint this state on the Dolo mission. I got a date with the K.
Hey, Jaina, why you running away?
Probably touch down when
Get in the car.
Oh my god, I'm getting
Yeah, that's right. That's right. Get in the car. Hop in, nice and slow. There you go. There we go. Hello?
Why are you taking so long? I saw you going backwards like 4 times. Why are you stopping?
Don't worry about why I'm stopping so much, alright? And I only stopped twice.
I'm your wife, Este.
Oh, that is.
I got your kids.
Damn it. Well,
No,
look,
no, no. You gotta tell me, is this someone else? Cause if there is, then I'm moving out, Este.
I only stopped twice, alright? I'll prove it.
A
God.
ver.
Okay, in order to prove that I only stopped twice in the last 5 minutes, we will now look at part C. Find all times t in the interval 0 to 5 at which the particle, which we'll call the car, changes direction. Then justify the answer. To solve this problem, we'll need to use the calculator to work with the velocity function we were given earlier. V of t equals -2 plus t squared plus 3t raised to the 6/5 power, minus 3t cubed. Since we're looking for when the direction of the car changes, we must set the velocity equal to 0 and see where it changes from positive to negative or from negative to positive, which would represent either forward or backwards motion. In other words, we're going to find the zeros of the equation. First, plug in the velocity, -2 plus x squared plus 3x to the 6/5 power minus x cubed, into y1. We must also adjust the window size. So, in the window setting, change the x min to 0 and the x max to 5 because of the interval 0 to 5. To get to the finding zeros option, press second, the calc button, and then 2. We have to realize that there are 2 places where the graph crosses the x-axis. These 2 locations are the zeros, the times that the car changes direction. To get our 2 answers, we have to enter a spot left of the 0 for the left bound, a spot right of the 0 for the right bound, and a guess for the actual spot of the 0. After doing this for the first 0, we get an answer of x equals 0.5360. Repeating the same process for the second 0 gives us an answer of x equals 3.3177. We now have our answers. The car only changed directions twice, one at 0.5360 minutes and one at 3.3177 minutes. In order to justify our answers, all we have to do is state the reason why we know that our answers satisfy the question. The question asks for all the times the car changed directions. We already have our times, and since the car changes directions when velocity changes sign, we can use the graph to guide our justification. The car changes direction at time t equals 0.536 minutes and at time t equals 3.3177 minutes because velocity changes sign.
Yeah, see, that's right. I only stopped twice. Stop calling me. Oh, damn. Past my house. Need to go back.
You again? Sir, you were overspeeding backwards. You know how awkward that is?
I was not speeding up.
Yes, you were.
Yes, you were, and I can prove it.
Part D. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. So to find out if the speed of the car is increasing or decreasing at time t equals 4, we will need the velocity function and the acceleration function, which is the derivative of the velocity function. And to say that the speed is increasing, the answer to both function when you plug in 4 to it has to be the same sign. And to say that it is decreasing, the answer to both function when you plug in 4 has to be the opposite sign. Now let's solve for v of t by plugging in 4 at our function using our calculator, and we will get approximately negative 11.4757. And now let's find acceleration at time t equals 4 by using n-deriv and plugging in velocity and plugging 4 using our calculator, and we will get the answer of negative 22.2957. So we can see that the sign of our answer on both function is both negative. Therefore, the speed of the car is increasing at time t equals 4.
I told you were overspeeding. I gotta be like that, man.
Oh, see, I knew it.
You what?
You're guilty. What are these two people doing in your car?
I'm just kidnapping them, that's all.
Oh, I should have known that. Can I see your gun, sir?
Oh, yeah.
Yeah. Look, you're under arrest. Let's go. Under arrest, sir. Oh, I am not drunk.
So the question and in order to say that the